Hello my fellow CAD lovers, and welcome to the part 6 of this tutorial on modeling a spiral casing in Autodesk Inventor. Now that we have the main case finished, we are going to move towards the outlet of the spiral casing. And what we are going to try to do in this part is to get all these components in place. We are going to start by creating some work planes, and from there we will create sketches for the sheet metal component 9020 and 2021, and then we are going to add these two components. We will finish with this flange and this last component. We are going to create the work planes and the sketches inside the master part, so let's switch back to the master part. Then we will add a new plane using the offset from plane method, and we are going to select the XY plane, and we want it to be at a distance of 750, so we will input 750. So this plane will be named WP19. Okay, from this plane we will create another plane, so we select it and we want it at a distance of 130. So this time we will input minus 130 so that it will be from left to right. And as you can see, the first plane is consumed. We don't want that, so we will select it and right click and deselect this consume inputs option. Okay, now we can see the first plane, and we will rename this one WP20. We will create a third plane, so offset from this one, and the distance will be 228, and with a minus sign in front so that we have it in the right direction. And as we did for the previous one, we will deselect the consume inputs and rename this WP21. Okay, now we will add our usual arc with the two lines to create the profile for the sheet metal components. So the diameter will be 700 millimeters, and we will start the first sketch onto this plane. So we select it and create sketch. We use the cycle tool as we did before, and we will input 700, and maybe I should rename this diameter as outlet diameter, which should be equal to 700. Okay, so now looking like this, we should, maybe we do not need to see all these, so we will just hide them, these two also, and so far so good. We do not need to see all these, so visibility off, much better. Okay, now we add the two lines we need, so from somewhere like this to the origin and back, we will project the y-axis onto the sketch so that we can add the symmetry relationship between these two lines, and using the y-axis as the symmetry axis. And we will use the trim tool to cut these parts, this one and this one. We make sure that these two lines are construction, and to finish we will add a escape first, a dimension, angular dimension, so the usual 0.5 degrees, and maybe we should also add a parameter for this. So I will finish the sketch first and then go to the parameters dialog, and I will look for the first one which is this one, so I will rename it opening angle, and this one will be the small one, and the value is 0.5 degrees. So now I will copy this and then paste, and also for this one, oops, paste. Okay, so you can see the value in this sketch is already linked to the parameter we just created. Okay, so this will be the 19. Okay, so now for the next one, we will show the work plane 20, and we will just copy this. So copy and select the plane, right click and paste. We will edit the sketch to make sure that this diameter is equal to the outlet diameter. So okay, this value is linked also as it should be. So we do not need to make change to this sketch, because as you can see, this is a cylindrical component, so the diameter at this location is equal to the diameter at that location. So we need to move to the next one, and we will have a 625 millimeters diameter. So we hide this first, then rename this to 20, and we will show this plane, copy this sketch and paste it on this one, then hide the plane first, edit the sketch and change this diameter to 625, and everything looks fine, so no worry to have. Okay, now that we have the 3 sketches in place, we can invoke the make part tool, and we will create the first component, which is 19 to 20, and we will be using the sheet metal template. We will select these 2 sketches, and the thickness will be our model parameter, then okay, and we are directly brought inside the assembly, where we can edit the component and create the lofted flange as we did a couple of times before. Then we will link the thickness as we also did many times before, and this will be pretty much all for this component. So we return to the assembly and back to the master part, make part again, 20 to 21, sheet metal template, then I should have renamed this first, so cancel, this will be 21, and then make part 20 to 21 millimeter, these 2 sketches, then the thickness, and everything is okay. So okay, double click to enter the edit mode, lofted flange, this one to this one, change the output style, okay, link the thickness, and we can also take a look on the flat pattern, looking good. So back to the assembly, save the assembly, yes to all, and okay. So maybe we should false alert. Okay, so now that we have these 2 sheet metal components created, we can move to these 2 parts. So to create this part, we are going to use the sketch for these components, since they share the same inner diameter, and then we will add an additional cycle to create the outer diameter. So back to the master part, we will invoke again the make part tool, and the component is P1 as part 1. I am very creative when it comes to name the part. So this time we will be using the standard template, and this sketch will be useful. We do not need parameters, and we will deactivate this option. And okay, so this is our new part. So we will enter the edit mode, and we are going to expand this and edit the sketch. As you can see, we have an opening here, so we cannot use it to create the part. So we will select the arc and make it construction. Escape to deactivate the construction tool. Now we will add a new cycle from this center point, and we'll make it big enough and accept the value like this. Next, we will use the equal constraint to make sure that these two are coincident. Okay, for the outer diameter, we will add an additional cycles. This time we will input a value, so it will be 720, and okay. Now we finish and create an extrude. So as we did before, we will select the region between the two cycles, so like this, and the extent of the extrusion should be 40 millimeters, and we will make sure that it is in the opposite direction, 40. Okay, now we can go back to the assembly. Now it is a good idea to create a section, because we are going to be mostly looking inside the components, and the way to do that is to move to this view tab and select half view section. And now we have to select a work plane or a face to use for sectioning. So we are going to move to the origin folder and select this YZ plane, and we want to flip this display side. So we right click on the graphic area, then flip section, and this is how we want to be looking. And I choose this configuration because it will be the same as what we have in the print, so it will be less confusing when moving forward. Okay, so for this component we still have to add this cut to finish the interior. We have more details on this view, so it will be a 650 diameter cut with a depth of 31 millimeters. Okay, so I'm going to double click again to edit the component, and we will add a new sketch onto this face, a new cycle like this, and 650. Right away, extrude, and we want to remove material, and 31 millimeters. And that's it for the component. So now we move to the next component, and we will do the things a little bit differently for this one, because as you can see, the component should be between this ring and this previous component, and the length of the component basically should be driven by these two components. So we will create this component so that it is adaptive. To do so, we are going to create the new component in the context of the assembly and not from the master part as we did before. So move to this assemble tab and use this create component tool, and as you can see, we have the create in place component dialog, and the first input should be the component name. We will enter P2, and for the template we will use the standard millimeter template. The new file location is the same as we used before, and we will keep all the options as they are and click on OK. As you can see, the new component glyph is now attached to the cursor, and we are prompt to select a sketch plane for the base feature. We are not going to select anything, but instead we are going to click on a free space in the graphic area like so. As you can see, we are in the standard part modeling environment, and we are not going to do anything. So we are just going to click return to go back to the assembly. here is the newly created component, and we will expand and select the center point or the origin point for the component. As you can see, it is placed where we click to place the component in the assembly. We want this to be coincident to the origin of our assembly. So here is the center point of the assembly. We want the two to be coincident. So what we will do to make that happen is we select this component, and inside the assemble type we will move to this productivity panel, and we will select this count and root component tool. And as you can see, the position of the component in the assembly tree has changed and is moved onto the top. This is what the tool do, and this is not a big deal, but what we wanted is to have this center point coincident to the center point of the assembly. And you can also see that the XY plane of the assembly and the XY plane of the component are coincident, same as the XZ plane of the assembly and the components. Okay, so this is what we wanted, and what we can do next is to drag the component and move it to the end of the tree just after the P1 component. Okay, now we can double click to start the edit of the component, and what we are going to do for this component is to use this face of the P1 component to create the first sketch, and in that sketch we are going to use this edge. So we will start a new sketch, and we are going to move and select this face. As you can see, we have a new work plane which is automatically created, and there is this icon in front of the work plane. This means that the work plane is adaptive. If this face is moved, the plane will follow. Okay, so now we will use the project tool to include this edge, and as you can see, the icon is also added in front of the sketch. If we increase this diameter, the diameter of the cycle will also increase. This is adaptivity in Autodesk Inventor. Okay, now we will add an additional cycle at this diameter 675 to create the inner diameter of the component, and we will perform an extrude up to this face of the ring one. Okay, so first we add an additional cycle, so the diameter will be 675, and we'll finish the cycle, then extrude. We select the region in between the two cycles, and for the extent, this time we will not use the distance option, we will change it to the 2 option, and we will select this face. Now you can see how the component is created, and when we will click on OK, you will see that the adaptivity icon is also added to the extrusion. So if we decrease the thickness of this ring, this face will move accordingly. Okay, so next we will add a cut to create this feature. So we will use a cycle of 685 millimeters, and for that we will create an extrusion with a depth of 30 millimeters. And to finish the component, we will add this chamfer tree at 15 degrees and this countable threaded hole. Okay, so first the extruded cut, we'll select this face, then create sketch, new cycle at 685. Am I right? 685. Okay, then finish, extrude. You want to cut, and the depth should be 30 millimeter. Okay, now we will add the hole, and we need to define a starting point first, and it should be on this cylindrical surface. And since we need to create a sketch first and then inside create the center point, we have to define a work plane for the sketch. So we have to create a plane tangent to this cylinder, And the way to do that is to use one of these options, and it will be this tangent to surface and parallel to plane. So we select that option, and we will first select the cylinder, and then we will use the XZ plane to define the parallel plane and then create the plane. Okay, now we can start a new sketch onto that plane, and we will just add a point somewhere like this. Okay, now we will add constraint, horizontal constraint, no, vertical constraint. You see the dot infinite line indicates how the constraint will be created, this point and the origin. And next we will add a distance of 66 millimeters from this end face. So dimension this to this edge, and it should be 66. Enter and finish. Now the all tool, we want this option, and as you can see the sign up one is already selected. The counterboard diameter is 40 millimeters. The depth is, if I recall correctly, 2 millimeters. It was not given on the print, so I have to make something up. So 2 millimeters seems good. And we will have a thread with a nominal diameter of 20 millimeters. So we will change this option to this one, and we want it to be an metric profile. The dimension should be 20, and we select a 1.5 millimeter pitch. And for the termination, click on this cursor icon to activate the selection. We will try with this cylinder, and as you can see, the hole will extend down to the far side of the surface. There should not be any problem with that, but I am going to use the XZ plane instead. And we can see on the preview everything looks fine and dandy. And for the thread depth, we will keep 40 millimeters. So we just click on OK to finish. Now we will hide all the work plane and take a look to make sure that everything is okay. So looks fine. The thread is created. We have the counterbar. Okay, now to finish the part, we are going to add a chamfer. So we select this edge, and in this fly out menu we can select create chamfer. By default we have this method which is at 45 degrees, so we want to change to this method which use distance and angle input. So the distance should be 3 millimeters and the angle 15 millimeters. So we'll input here 3 and there 15. Now we have to select a face, and we will select this face, and maybe we have to reselect the edge, so we select this one, and you can see how the chamfer is created. It looks good. Okay to finish, and we are done with this component. So now we will return to the assembly and take a close look on the result. Looks fine and dandy. Okay, all right, let's move on. We still have the flange and the shim at the end of the outlet, so these two to do. And this time we are going to start from the master part, since we need to use this outlet diameter as input, as well as the thickness of the sheet metal components. And we will also create these two components a little bit differently, since there will be reuse for the inlet. So as you can see, these are the same two components. Okay, so let's get to it. We are going to switch directly to the master part, and we will invoke the make part tool. We will create the first one, which is F1 as flange part 1, I guess. And what we want to use is only the thickness and the outlet diameter. And maybe I should do this a little bit differently. I want to use the inlet diameter instead, so we will cancel this and we will right click and select parameters. Now we are going to look for a 700 millimeters value, and it should be for the dimension we use when we create the WP location sketch. There it is. We will rename it inlet dia, and I should have done it right away in the beginning, and the outlet diameter will just be equal to the inlet diameter. So this should be equal, so Ctrl V. So we're done, and maybe we should check this from this one maybe. So we make it visible, then edit, and we have not the correct one, so let's hide this, and maybe it is this one. So edit sketch, and this is the inlet diameter. Okay, so just to make sure I did the proper modification, so let's hide this and let's go back to the make part tool again. So we will use the thickness and the inlet diameter, this one. Okay, and we will make sure that this one is unticked. We will name this as F1 template standard millimeter, then OK. And we have the component created. And as for the previous components, the component origin is coincident with the assembly origin. For the moment, we are going to leave it like this, and we will create a new sketch on the XY plane. So we will have a first cycle. We will add a dimension next. So this value should be the inlet diameter plus 2 times the thickness. So click on this and list parameter. So we select inlet diameter first plus 2 multiplied by, we are going to look for the thickness, and OK. So this will define the inner diameter of the shim, and then we will add a second cycle with a diameter of 787.5 millimeters, 787.5, and we finish the sketch, and we will extrude the region in between the cycle, and we want the thickness to be something like, let's say, 7 millimeters. So this one will be 7 millimeters. And as you can see, the component is currently hanging in the middle of the spiral case. We are going to return to the assembly and add the assembly constraints required to position it adequately. For now, there is this thumbtack icon in front of the component name, and this means that the component is grounded and it cannot freely move. So if we try this free move tool, we cannot grab the component because it is grounded, obviously. So we are going to remove this ground constraint. So we right click and deselect grounded. Now if we try again, so free move, we can freely move the component. Okay, so now to add constraint, we will use this constraint tool inside the relationship panel of the assemble tab. So constraint, we will first constrain this face to this face of the sheet metal component, and as you can see, the default mate option is not convenient with. That's why we are going to switch to the flush option. Then we will click on apply. Next, we will align the axis using this insert option, and we will select this edge for the shim and this one for the sheet metal component, and we will switch to this align option for the correct solution. OK to finish, and now the component is properly positioned. Now using the same technique, we will create the mounting flange. So back to the master part, make part, we will use the inlet diameter as parameter, then the thickness just at the beginning, and we want it to be F2, then the standard part template, we'll unlink this. OK, and double click to enter the edit mode. We look for the XY plane, then start a new sketch. First cycle this one, the dimension and the formula, we can reuse what we had before. So this one, inlet diameter plus 2 times the thickness, then OK. Next, a new cycle, and the value will be this time 921. Then we finish, and our usual extrude to a distance of 90 millimeters. And now we want to add some holes, and where are they? So you know that the diameter will be 35 millimeters, and we should have 36 holes at a diameter of 857 millimeter, and this means 10-degree angles between holes, so that the first hole will be at 5 degrees from the horizontal or vertical axis. So we select this face, then a new sketch, add a new cycle, so, and now a line up to the cycle, then we will escape to finish the line first, then we want to project the x-axis onto the sketch, then we add some dimensions, so this should be 5, and this should be 857 millimeters, and there we go. So finish, we create the first hole, so the diameter, the center one, this one, the diameter should be 35 millimeters, and the hole should be through all. OK, and now to finish the part, we use the circular pattern tool to duplicate the hole. So this, we want the rotation axis to be the Z axis, and the number of holes to be 36, and there we go. We finish and return to the assembly. Then, as we did before, we remove the grounded, and now we will add the constraints we need to properly position it. So we will start with a made constraint, so this face to this one, then apply, we will drag this away like this, and then we will apply an insert constraint. The first selection will be this edge, and the second one will be this one. OK, then apply, and for this first one only 2 constraints were enough, but for this it will not be the case. As you can see, the part is still able to move, so we are going to add a third constraint to fully constrain it. Okay, so what we are going to do first is to hit the cancel button, and then we are going to move into this origin folder for the component, and we are going to show the YZ plane. So we select it and switch on the visibility, and we are going to do the same for the origin folder of the assembly. So we are going to activate this YZ plane again, right click on visibility, and now we are going to evoke the constraint tool again, and we are going to make sure that the mate option is activated. So next we select this plane and we mate it to this one and apply. Now if we try to move the component, you see it is not longer possible and the component is fully constrained. Now we will click on cancel and then hide this plane, and the same for this one. And that's it for the outlet. Now we are going to reuse these two components to complete the inlet. First, we are going to remove the half section view, so we'll move to this view tab again and select end section view. Next, we are going to move back to the assemble tab, and in the component panel we are going to click on this place component tool, and you are going to look for the F1 component, this one, then open, and we are going to drop it somewhere like this, then right click and OK. We are going to do the same for the second one, so F2 component, which is this one, then open, and again we drop it somewhere in the graphic area like so, then right click and OK. Now we will apply some constraints, and we will start with this component, so right click and constraints, and we start as usual with mate constraints. So we start with this face and we will mate it to this one. We make sure that the normal are facing in the same way as you can see, then apply. Next we will use the insert option, and we will select this edge and we will mate it with this one. As you can see, nothing happens. We need to use this align option and then apply. Okay, so this is all for this component. Now we are going to do the same for this one. So we'll first mate this face to that one, then apply. Again, the insert this edge to this one, then we switch to this oppose option for the solution, then apply. And as we did for the previous one, we are going to add a last constraint to fully position the flange number 2. So we are going to expand the component and we are going to show the YZ plane, so right click and visibility, and then we are going to do the same for, should not be the YZ plane, excuse me, this should be the XY plane, so visibility for this one, and then we are going to toggle off this and show the XZ for the second flange. And again we are going to activate the constraint tool, and we are going to select this plane as the first input and this one as the second, and now the component is fully positioned. So we will toggle the visibility off for this, collapse the group, and we will do the same for this one, and that's it for the inlet. Okay, finally we have something which is quite looking as the final model. Now we have to work the internal details, so we will have some flow guides inside, and the exterior detail will be some stiffeners, and we are going to start all of that in the next part. So I hope to see you then, and thanks for watching.